In this video, we'll talk about how escaping closure can cause reference cycle inside our app. Here we have a demo application that has two view controller. The start view controller that has a single button that goes to the leaky view controller, and the leaky view controller that has a start timer button that's bounded to the start timer IB action, and the start VC that allows us to go back to the start view controller. Notice that here we are not pushing new controller to the stacks. We are changing the root view controller of our window, because if we're pushing it to a stack, we're still actually holding a reference to that view controller. However, if we completely change that the root view controller, we effectively discarded the reference to the current view controller and replace it with a new one. So the automatic reference count, without the reference cycle, the automatic reference counting should be able to pick up the previous view controller and deinitialize it. And we'll see how that works just in a moment. However, right now, the problem is if we hit the start timer button, you can see here we initialize the timer with a closure. And this closure will be triggered every 1 second, and it's going to repeat forever. However, the strong reference cycle appears when we capture self by referencing it within our closure. Remember, a closure will automatically capture the object that was used inside the closure from its current context. In this case, self will be captured using a strong reference. And since leaky VC, in this case self, also holds a strong reference to the timer, we are creating a reference cycle between the timer and the leaky VC. If we run our app right now and we go to the leaky VC, we hit start timer, we'll see the counter starting to count every 1 second in our console. However, if we go back to start VC, in theory, without a reference cycle, the counter should stop because the leaky VC should be deinitialized. However, because the reference cycle exists, the counter just keeps counting forever. And in fact, if we go back to leaky view controller and hit start timer again, we'll see another timer start. If we go back to VC and then go back to leaky view controller and hit start timer, we have 3 timer instances, therefore 3 leaky VC instances running simultaneously. So how do we debug this? Normally, you would just notice the reference cycle that you created inside your code. However, there's a couple of tools that may help you do this, and one of them is the memory graph. If you clicked this little button right next to the view hierarchy button that we discussed before, you'll see the current VC instance that are in our memory. And here you'll see we have created 3 leaky VC instances at 3 different memory addresses, and all of them are running the timer. And we can see its effect in a counter right here. So here's one of the way of detecting view controller. Now, the impact of this seems pretty trivial in this case because each view controller doesn't occupy much of a memory. However, in real world scenarios, it wouldn't be that common that our view controller are this small. In fact, I made an example where we load a buffer of 500 megabytes of memory because the buffer is essentially an array of 8-bit integer, and if you recall, 8-bit equal to 1 byte. And if we created 5 million of them, we're essentially allocating 5 megabytes of memory. And now if we redo the operation that we just did, in this case, if we run our app and initialize a leaky view controller and use the start timer button to trigger the reference cycle, and then we go back to start VC and initialize another leaky view controller, you'll see our app is currently using almost 1 gigabyte of memory. We can do that a couple of times, and you will see the memory usage increase drastically. We need to use the start timer. Again, need to use the start timer to trigger the memory leak. And use start timer again. Go back to start VC, use the leaky view controller. Now our app are using almost 2 gigabytes of memory. Now, modern iPhone has roughly 4 gigabytes to 6 gigabytes of RAM, and it wouldn't be long before iOS decided to terminate our app because it's using significant amount of memory. So the more important issue is, how do we fix this? Luckily, it is pretty simple. All we have to do is just explicitly saying that we are going to capture self using a weak instead of strong reference. Recall that on the website, we talked about how we can create a capture list using this syntax right here. And in fact, we can say, how should we capture each of the object using this weak notation? Because if we use a weak notation, we are saying that we will capture it using a weak reference. So as you can see, once we capture it using a weak reference, self effectively becomes an optional. So you can either use optional chaining or use a guard-let statement to make sure that self is actually an instance. Just like that. And right now, if we run our app again, we guard-let, we should be able to see our app no longer creates reference cycle. So we initialize the leaky view controller. Our app takes 500 megabytes of memory. There's no escaping that because right now the instance is currently active. But if we start our timer and go back to start VC, previously remember that this will trigger a memory leak and our memory will never get deallocated. Right now, because of the introduction of weak self, the leaky VC instance actually get deallocated properly. Now, even if in the case where there's no memory leak, weak self can still be useful because it avoids delayed deinitialization. So if, let's say, we've set our repeats to false and with time interval 10 seconds. Now, if we don't use weak self, even if it will not create a memory leak, as after 10 seconds, this timer is fired and then it gets invalidated because repeats equals to false. However, sometimes in this case, we still want to use weak self because we don't want the deallocation to be delayed. You can imagine if right after we initialize a timer, you want to deallocate, we just discarded the leaky VC and we want to deallocate it and deinitialize everything that's related to it. Because of this strong capture of self, we will not be able to deinitialize it after 10 seconds. Sometimes this can lead to unexpected behavior as you are not expecting yourself to be still active after, let's say, transitioned to another screen. So even if this is technically a memory leak, you sometimes still want to use weak self just to avoid delayed deallocation like this one. Also, in some networking scenario, if your networking request takes super long, effectively forever, this could accidentally capture view controller instances and causing it to not be able to deallocate it as well. That's the end of this video. Thanks for watching, and I will see you next time.